before I bribe you, here we go. We're taking a peek at new Unit 3. And I love the beginning of it because I think it's pretty. You're like, man, are we back in elementary school? We're talking about lines of symmetry. Do you agree this cute little parabola has a line of symmetry right here, meaning if I folded it over, would it land on top of itself?
Yes.
Yeah, okay, cool. So this one has a line of symmetry. And then over here, this guy's line of symmetry happens to be horizontal. You down with that? This guy has got 2 lines of symmetry. Can we have more than one line of symmetry?
Yes.
We can. You guys, for something to have a line of symmetry, the 2 halves must... Anyone?
Match.
Yeah, true.
Each other. Exactly.
Ooh, that's where my head was. I'm not saying you're wrong, Blake, but my head was they must match exactly. Point symmetry. What we just discussed was line symmetry. If something has point symmetry, just means that there's a point that it could spin on, you guys. That the most common type of point symmetry is always about the origin. I'm just going to throw that in right there. And it could be rotated 180 degrees and land on itself. So for example, look at this cute little S and watch my hands. If I rotate this 180 degrees, is it what it started as?
Yeah.
Yeah, so that's going to be called point symmetry. Let's go back. What about this line N? If I rotate it 180 degrees, is it what it started as? Okay. What if I went 360 degrees?
Yeah.
Doesn't everything have 360 degrees? So 360 degrees doesn't mean anything. If I take anything and I rotate it 360 degrees, it's going to be back to itself. You know what I'm saying, people? Okay. What about this little cutie? 180 degrees. You think that this guy? Yup. He lines up the same. And same with my graph of 1 over x. Okay. So here's where the bribing comes into play. You guys, we have things called even functions and odd functions. Okay. An even function are these 3 examples. So I'm just going to zoom in on them. Boop. An even function. Where would you say my line of symmetry is? It's going to be, Kate, talk to me. She's saying it's the y-axis. If I fold it over the y-axis there, if I fold it over the y-axis there or there, does it land on top of itself like a nice sandwich? Has anyone ever made a PB&J? Here's my question. Kate Burke. If this is the point, let's go say if this is x squared, this is the point 2, 4. What would its equivalent point over here be, Kate? Yeah. So you guys, would you say the x coordinate is negated, but my y coordinate stays the same? What about over here? What if I've got this point? Now, let's make it up. What do we want this point to be? 3, 4. What would its reflected point be? Good job. Porter, let's make this one up. What do we want this one to be? Let's say 1, 2, 3, 4, 5, 6. You tell me. 6.
6, 1.
Sure. What would this equivalent point be over here?
-6, 1.
I dig it. So anytime we have an even function, do you agree that x's are opposites? One's positive, one's negative. But what happens to the y? Stays the same. Okay. So Kate got her candy because she said even functions are symmetric about the y-axis. An odd function, not quite, because if I folded it over here, buddy, wouldn't it land down there?
It'd be the y equals x-axis.
Not quite, because then this would land, I can't even picture that. It'd be like this.
Like the weird inverse thing.
Not quite. Blake says the origin. So you guys, the odd functions, they have that point symmetry. So this one's going to be point symmetry, or you might say spin. Whereas the even function does have that line symmetry where we fold. So maybe that one you say that you're folding. Sandwich. PB&J with 1 slice of bread. Never talk about that again. Okay. Biscuit. If this is the point, let's say this is the point 1, 5. I'm just making things up. Biscuit, what would its revolved point turn into, do you think? Beautiful. Mateo, if this is the point pi over 2, 1, what's its revolved point?
-pi over 2 over -1.
Love it. So look at the little difference, Mateo. With the evens, my x's change signs, but my y stayed the same. With the odd, what are my x's doing? They both change signs. That's just what I want to plant that seed. So over here, I kind of gave a textbook synopsis of what's going on. So check this out, you guys. Would you agree that we have even functions here because they have that line symmetry over that y-axis? You feel okay with that? There's my peanut butter and jelly sandwich that I'm folding right there. These guys are rotatable. If I flip, watch this. If I rotate this 180 degrees, do those graphs look exactly the same? Yeah. Okay, so here comes some textbooky information. If they both start with the point AB, check this out. Ready, Tatum? Okay, let's actually put some fake points on here because I think this is going to help. Give me a fake point right here, somebody. Fake point. 3, 2. I'm going to go with like 3, 5, just to be a little bit more realistic. What about over here? Okay, great. Give me a point. Let's do the same one over here. Let's do a 3, 5 over here. What would this reflected point be? Okay, because me as a student, I did better with numbers rather than variables. But look at this. To prove if something's even or odd, you always switch the x value. Look what they're saying. If my function starts as f of x, that's my function, always switch the x, meaning the x is always going to be negative. Do you agree these x's are negative and these x's are negative? But in an even function, what happened to that y coordinate? It stayed the same. My b stayed the same. What about my y coordinate over here? It's the opposite. So look what I said. In an odd function, not only is the a going to be the opposite, but the b is also going to be the opposite. And you're like, okay, I'm not quite sure what you want me to do with that. Let me show you what I'm talking about, people. Let me show you what I'm talking about. Determine whether each function is even, odd, or neither. Guys, I'm going to give you a sketch of this graph. X to the fourth. Anyone have any idea what that's going to look like? If this is x squared, what's x to the fourth?
Very wiggly.
X to the sixth. Check this out. Let me show them to you. We got x to the fourth. And then we got x to the sixth. Oh, I should probably give you x to the second to start. We'll do that there. And we'll go x to the eighth. Check out all these ditties. So they all kind of have the same shape, would you say? They have the same shape, and then how I describe it, as the exponent gets bigger, it gets squattier. It just gets like a little rectangular at the bottom because things grow so quickly, but they all pretty much have the same shape. So you guys, let's just draw a sketch. It just looks like that pretty much. Yeah, my graph looks actually terrible. It just looks like this. Boop. I do not care how accurate it is. Prediction, even, odd, or neither based on that picture. You think, Coop, that it's just going to fold over that y-axis. I agree. This is how we have to prove it, you guys. So I want you to say, my function was x to the fourth. I'm going to write that as an f of x, okay? My function is x to the fourth. To prove if anything is even or odd, you always make the x opposite. Look at both of these. Always change the x to a negative. So I'm going to say, all right, f of negative x. I'm going to put in a negative x for my variable. Anywhere I see a variable, I'm going to put a negative x in for it. And then we want to simplify it. What is a negative anything to an even power going to turn into? A positive, right? Like negative 2 squared is positive 4. So could I say, I just want to simplify this, and that gets me positive x to the fourth. Yeah. Okay. Do you guys remember, me in high school, I always said I replaced every f of x with a y. Do you remember me telling you that? Yeah. F of x to me was very confusing, and it's the exact same thing as y. So I literally would just do this every time. So if my function started as x to the fourth, and it ends as x to the fourth, or my y was x to the fourth, and it ends as x to the fourth, did I end with what I started with?
Yes.
Yeah, sorry, I want to group these together. Can I lock that? Let's lock that thing down. So, check this out. When I plugged in a negative x, did I get what I started with? When I plugged in a negative x, did I get what I started with? Yes, because when I plugged in a negative x, I got exactly what I started with. I'm going to say it's even. And I'm going to use this fancy notation. I'm going to say, therefore, it's even. And I'm going to go really mathy on you real fast. I really thought I locked that thing down. Apparently I didn't. Let's try that one more time. Why isn't it locked? So the fancy notation is saying, hey, when I plugged in a negative x, I got what I started with. That's how we know that it's even. Let me say that one more time. You are always going to plug in a negative x for every single function. If you get what you started with, you know that it's an even function. It's going to be symmetrical about that line y equals y-axis. Let's try this guy. We're going to do the same thing, but I want us to start with saying, all right, my function was x plus 2.
Yes.
Yes. All right, Coop, I want you to help me. What would plugging in a negative x do right there, buddy?
It would turn that to negative x plus 2.
Thanks, bud. Now, here's what you got to think. Cooper, is that what I started with?
No.
No, because therefore it's not even, because it's not what I started with. Is it exactly, look what, for it to be odd, look what would have to happen, you guys. What would have to happen for something to be odd? Exactly. When I plug in a negative x, I would have to get the exact opposite of what I started with. Did I get the opposite of my x?
Yes.
Did I get the opposite of my 2?
No.
No.
Therefore, it's not.
Therefore, it's going to be neither even nor odd. Let's try this one, you guys. This one I gave a lot more x's, so let's try this. Ready? Bet, can you keep your hands to yourself? You guys, first step every time. You plug in a negative x in for f. Every time. We're going to replace the first x with a negative x. I'm going to replace the next x with a negative x. Every x gets replaced with a negative. I didn't put that one in parentheses just because he didn't have an exponent. Then you want to simplify. Let's simplify. When I plugged in a negative x, does this thing change at all? Nah, it's just negative x. What about a negative to an odd exponent? It's going to be a negative. So could I say minus x cubed? Okay. Mr. Ritzy, when I plugged in a negative x, did I get exactly what I started with, which was this? No. Is everything opposite?
Yes.
If everything's opposite, this is what we'd say. When I plugged in a negative x, I got the opposite, how we say that in math is negate it, of what I started with. And because that's true, Ritzy, you'd say, therefore, it's even or odd? Odd. Let's look at the graph real fast. X plus x cubed. Let's go take a peek at that graph. X plus x cubed. This one's going to be more wiggly. Oh, not much. All right. Does this one look, if I were to draw this graph? It's okay. I appreciate the collaboration. If I rotate this 180 degrees, oh, I locked it. Ah, shoot, I locked it. Oh, there we go. Is that what I started with?
Yes.
Yeah, that's why it's going to be odd. Okay. This is funky, though. So there's the graph of it. Our prediction is neither. Here's how we prove this, you guys. You always plug in a negative for the x. We replace every x with a negative x. Mateo says, all right, when I simplify this, we're going to get a negative x. What about a negative to an even power? Awesome. Mateo, is that what I started with? Oh, wait, I'm sorry. I left off a cube. Boop. Is that exactly what I started with?
No.
Not quite, right? Because that guy's opposite. Is everything opposite?
No.
No. Because neither, it's not the exact same, it's not the exact opposite, we're going to say neither. One last one for me. 1 over x looks like this. Predictions. Odd. Let's do it, you guys. What's f of negative x going to get me? 1 over negative x. What's the only way I could, how can I simplify that? Is that the same as this?
Yes.
Is that the same as this?
Yes.
Okay. All of these are equivalent, you guys. They're the same thing. Is that what I started with here?
No, but it's opposite.
Is it exactly the opposite? Is it negative 1 times it?
Yeah.
Yeah. So how we say it is we say, okay, when I plugged in a negative, I got the opposite of what I started with. Because it was opposite, we're going to say
So that's not.
odd.